Okay, so last part of the review is looking at the inequalities. And so we're going to start with if you were to graph it, it would be the shape of a parabola. And so what that means is that if you were to graph it, looks like a parabola. I don't know exactly how this one looks, but something, along those lines. And the question is, when I plug in x, when are my values less than or equal to 0? So that would be basically it's asking when is my results, when are my y values negative, right, or equal to 0? And so what we're going to do here is go ahead and factor this. So this should factor into plus 4 and plus 1. We want to know when that's less than or equal to 0. Well, the x-intercepts are going to be at -4 and -1. So on this number line, we'll go ahead and we'll go ahead and include these values. So -4 and -1. And so we include those values because I'll go ahead and draw an accurate picture of this. This one wasn't quite accurate. Let's see. So here we are. And so it's going to look something like this, right? So I can tell from the picture that the answer is going to be all the values between the x-intercepts. But it's going to get a little bit more challenging as we work through some of these problems. So really, it's kind of best to go ahead and test some points and see if they work. So we want to test points within the subintervals. So I'm going to test a point like -5, -2, and 0 is usually pretty easy to test. And kind of like what I did a couple pages back, I'm probably going to plug it into the factored form. It's just going to be a little bit easier to test it, make life a little bit easier. So if I plug in -5, I would get -1 times -4. And we want to know if that's less than or equal to 0. That would come back as +4 less than or equal to 0. 4 is not less than or equal to 0, so that is false, right? So don't shade there. Now we'll try plugging in -2. So if I plug in -2, -2 plus 4 is +2. Then -2 plus 1 is -1. Is that less than or equal to 0? Well, you get a negative number. Negative numbers are less than or equal to 0. So now you shade between right there. Then we'll try out 0. So if you plug in 0, you get 4 times 1. Is that less than or equal to 0? And so 4 is not less than or equal to 0. False. So we don't shade. By the way, this one was true. Write that down. So the way you would convert this to interval notation is from -4 to -1 and bracket those in. All right, so the next one, pretty much the same deal. To be honest, it's going to look pretty similar. So we go ahead and factor this. And this time we want the results to be greater than 0. So let's see, x. Let's see, I believe it's going to be a -8 and a +4. So those intercepts are a +8 and -4. And once again, if you were to kind of visualize this, you could probably figure out the answer without even doing anything else from here. But like I said, it's going to get a little bit more harder as we move forward. So I'm just going to kind of be pretty traditional on how you solve these. This time, those x-intercepts will not count because we're looking for values that are greater than 0. And so when you plug that in, it actually causes it to equal 0. So those cannot be part of my solution set. And so now we'll go ahead and test like, I don't know, like -5, 0 is always good, and then like a 9. And if it works, great. If it doesn't, that's fine too. Just don't shade. All right, so we'll plug it into the factored form. So when you plug in -5, you're going to get a -13 times -1. And is that greater than 0? Yes, because the negative times the negative is positive, so that comes back true. Okay. Now we'll try plugging in 0. If you plug in 0, you're going to get -8 times +4. Is that greater than 0? No, that's going to come back as false. Okay. We won't shade here. We will shade, though, on that other one that we just completed right there. And then for our last subinterval, we'll try 9 out. So if you plug in 9, you're going to get 1 times 13. Oops. Yes, 13. Is that greater than 0? 13 is greater than 0. That is true. So we go ahead and shade. There you go. Now the way we convert this to interval notation, we can say everything from negative infinity to negative 4 is good. Union, everything from 8 to infinity is good also. And there you go. Okay, so on these, we had 2 x-intercepts. Moving forward on the next couple, we might have 3. And so we'll probably see that on this one. So what's going to happen is you'll just have more intervals to test. But other than that, the process doesn't really change. All right, so this one, we want to figure out when it's less than or equal to 0. So we're going to start by doing factor by grouping. So we'll pull out an x squared and a negative 1. So let's see, that'll leave us with x plus 5. Pull out that negative 1. That'll give you an x plus 5. Figure out when it's less than or equal to 0. Then we'll factor out the x plus 5. And then we have x squared minus 1, which is the difference of 2 squares. So we can factor that. So we get x plus 1, x minus 1. So this particular inequality has 3 times when it will equal 0. And that's, we want to figure out when it's less than or equal to 0. So all those points will actually be part of my solution set. So let's see, we'll put negative 5 right here, negative 1 right here, and positive 1 right there. I know I'm not spacing them. The spacing's a little off, but I did that kind of on purpose, so I have room to kind of do my work to show if it's part of the subinterval or not. So that's kind of the reason my spacing might not seem right. Okay, so we will go ahead and include all 3 of those points. Okay, and so when we test, we'll test stuff like negative 6, negative 2, 0, positive 2. You could test different values if you really want, but those are the ones that seem the easiest to me. Okay, so once again, I'm gonna plug it into the factored form when I test it. It'll just make life a little bit easier. So if I plug in a negative 6, I would get negative 1 times negative 5 times negative 7. And we want to know, is that less than or equal to 0? Okay. All I did was plug it in for x in all 3 of those spots. And now I'm just multiplying those results together, which is positive 35, which is less than or equal to 0, false. So we will not shade right there. Now we'll try negative 2. So once again, I'm plugging it into those 3 spots. So let's see what I get. I get a 3 times a negative 1 times a negative 3. We want to know if that's less than or equal to 0. And actually, I apologize, I did actually make a mistake here. That should be negative 35. That should be true. And so I should actually shade right there. I'm glad I caught myself, but apologies. I'm sure some of y'all were like, no, what is he doing? So my apologies. So yes, we will actually go ahead and count that interval. Negative times a negative is positive, but then times a negative again goes back to being negative. So my apologies. Okay, on this one though, 3 times negative 1 is negative 3, and then times negative 3 is positive 9. So this one comes back as false. There we go. All right, we have 2 more to test. Hopefully I can fit them in. So let's see, if we plug in a 0, what's going to happen is we're going to get 5 times 1 times negative 1, and we want to know if that's less than or equal to 0. And so when you multiply this all together, you get a -5 less than or equal to 0. That comes back as true. We'll go ahead and shade that part right here. Right, and then the last one, we plug in +2. So let's see, we get a 7, a 3, and a 1. Is that less than or equal to 0? Well, you get 21's less than or equal to 0. That doesn't seem right, so false. And so we're not going to shade that area. And so your interval solution from here is going to be -infinity, -5, including it, union. Then we're going to go from -1 to +1, and that's it. So if you plug in any of those numbers inside those two intervals, it will result in a positive statement with your inequality. Okay, so I got one more similar to this, and then we're going to look at the ones that are rational, which are fractions. Okay, this one actually shouldn't be too bad. So we can start by factoring out an x squared. And so we're going to be left with x minus 6 is greater than 0. So your two solutions here are just 0 and +6. So actually, I'm back to only having two solutions. Okay. You'll notice because of the inequality sign, it's impossible for those to be part of my solution. So 0 and 6. And so they're going to have to be open circles because those values make it equal 0. I want to be greater than 0. So once again, we're going to test some points like -1, +1, and 7. All right. So let's get started. Once again, I'll plug it into the factored form. So let's see. I'm going to have -1 squared times -1 minus 6, which is -7. We want to figure out that squared, is it greater than 0? Well, I get 1 times -7. -7 greater than 0? No, let's make that false. Okay. How about 1? Let's try plugging in 1. So if we plug in 1, if we plug in a 1, so we're going to have 1 squared times 1 minus 6, which is a -5. We want to figure out, is that greater than 0? So we get 1 times -5. Is that greater than 0? Is -5 greater than 0? That's false again. So we don't have anything yet. Let's see what happens with our 7. So if we plug in 7, we get 7 squared, and then 7 take away 6 is +1. And we want to know if that's greater than 0. So we get 49 times 1, which, yes, that's going to be greater than 0. So we finally got one that was true. So we'll go ahead and shade that direction. So it's going to be from 6 to infinity. I just want to point out, now if that symbol would have been like this, if it would have been greater than or equal to, then 0 would have been part of my solution set, even though these two other intervals would not have been. That the only thing that would have changed is that 0 would actually all of a sudden been part of my solution set. And same thing with 6. 6 would have been, we would have bracketed that value in. So just pointing that out, that how that inequality sign can really change things up. Okay. Last two, and the differences we're going to deal with fractions. And so the approach is similar, but to figure out those key points is a little different. So what you're going to do is you're actually going to find the x-intercept of the expression, what makes that equal 0, and then you're also going to figure out the excluded value, which is basically the vertical asymptote if you're to look at this on a graph. So we'll start with the x-intercept. What you do is you take the numerator and set it equal to 0 and solve. And so that should be +6. So +6 is going to be that's going to be one of my crucial points. And because that makes it equal 0. And so that means that my graph it's crossing the x-axis at that point, and there's a sign change. Okay. The vertical asymptote, you take the denominator, set that equal to 0, and solve, which is going to be -2. And so I'm just going to do a little rough sketch just so we can see this. So my x-intercept is somewhere over here at 6, and my vertical asymptote is somewhere like right here. And so I'm not sure exactly what this looks like, but it's probably something like this. Okay. And then the other side is probably something like this. Okay. And so what's happening is there's a sign change at the vertical asymptote. It's going from going up to being a really big positive number to turning into a really big negative number. And then the x-intercept, it crosses right there also, and so there's a sign change. And so those are why they're your key points on your number line that you want to put there. So I'm going to go ahead and put -2 here. I'm going to put 6 here. And then we want to test some points like -3, 0 would be an easy one, and then maybe like 7. Okay. And let's see. So the x-intercept could be part of your solution, but it's not because of the inequality sign, because it says the greater than. So if you plug in 6, it causes your expression to be 0. And so it would come back as false, right? And then -2 is off limits because all vertical asymptotes are off limits. You can't even plug it in to test it because you get undefined. All right, but let's go ahead and test these subintervals. So let's see, we'll start with -3. So let's see, -3 minus 6 over -3 plus 2. Is that greater than 0? And so let's see, we're going to get -9 over -1 greater than 0. +9 is greater than 0. Comes back as true. We'll go ahead and shade right there. Now we'll try plugging in 0. So 0 minus 6 over 0 plus 2. Is that greater than 0? We end up with -6 over 2, which is -3. Negative numbers are not greater than 0, so that's false. So you don't bother with shading that part right there. Okay, now we'll try 7. So 7 take away 6 over 7 plus 2. Is that greater than 0? We end up with 1 over 9. 1/9, that's a small number, but it is greater than 0. So that comes back as true. And so we shade that direction. So our intervals are going to be from -infinity to -2, union from 6 to infinity. 6 to infinity. Okay, last one. It's going to be done the same way we just saw here. The only difference is in its current format, that's a pretty difficult question to ask. You know, when is it going to be, you know, less than or equal to 5? It's going to make life a lot easier if we make it less than or equal to 0. And so that's the first thing we're going to have to do here. So we're going to go ahead and subtract 5 from both sides. So let's see, we got x plus 3 over x minus 4. Now we have a -5 right there, less than or equal to 0. I kind of left some space here for a reason. Because what's going to happen is I want to bring this together as a single fraction. Once again, it's just going to make everything a lot easier. So what I'm going to do is I'm going to multiply the top and bottom by x minus 4, which basically I'm kind of like, I'm multiplying by 1 basically, okay? It's disguised, right? But and so what that's going to do is it's going to allow me to bring these two together as a single fraction. So let's see what we have here. So x plus 3 over x minus 4 minus, and then here I have 5 times x minus 4 all over x minus 4, less than or equal to 0. And so now what we can do is bring this together. Now you'll have to be careful. When I bring this together as a single fraction, I need to distribute that -5 to both parts, and so the negative included. If I don't do that, then that's going to cause some issues. So I should end up with, let's see, x plus 3 minus 5x, and then that turns into a plus 20, okay, all over x minus 4, which is less than or equal to 0. Now we'll combine like terms. I'll move it up here, try to keep it all on the same page. So x take away 5x should be a negative 4x. 3 plus 20, that will be plus 23, all over x minus 4. We want to know when that's less than or equal to 0. All right, so to find the x-intercept, set the numerator equal to 0. So I'm going to go ahead and add 4x to both sides. I could have subtracted 23, doesn't really matter. So 23 equals 4x. Divide by 4, and so yeah, we get a fraction, but don't let that worry you too much. So 23 over 4, pretty ugly looking too, but anyways, that's going to be my x-intercept. If you want it as a decimal, it's 5.75, so it's like 5.75. Okay, the vertical asymptote, so that was labeled that as our x-intercept. If you want the vertical asymptote, you take the denominator and set that equal to 0, which would just be x equals 4. Okay, so by the way, this as a decimal would be 5.75, just so you know where to put it on the number line. So we'll go ahead and pop the 4 right here. We'll pop the 23 over 4 right here. So we want to test some values. An easy one to test would be like 0. And then something between 4 and 5.7, which would, 5 would probably be the best. And then test something like 6 over here. Okay, so I know this has been a lot of work, okay, but we're almost done. We just got to plug and go in. Real quick, my x-intercept is actually included. So I actually do want to include 23 over 4, because that would cause the expression to equal 0, which is less than or equal to 0, which, because of my inequality sign, that's good. 4 cannot, because it's the vertical asymptote. So that vertical asymptote will always be an open circle. Okay, so we'll start with 0. So if I plug in 0, I'm kind of running out of room, so I'm going to do a lot of this math in my head. If I plug in 0, I'm going to get 3 over negative 4. Is that yeah, I'm plugging it into the original. It doesn't really matter, actually. I could have plugged it into this bottom one if I really wanted to. But anyways, is this negative number less than or equal to 5? That comes back as true. That comes back as true. So we'll shade. Okay. Now we'll try plugging in 5. Once again, you could plug it into either one of these. Might be a little bit easier to make a judgment call if you plug it into the one we simplified. So I'm going to go ahead and do that. So let's see, negative 4 times 5 plus 23 over 5 minus 4. Is this less than or equal to 0? 23 right there. So I'm going to get negative 20 plus 23 over 1 less than or equal to 0. So I end up getting 3 over 1 less than or equal to 0. That's going to be false. So we don't want to shade that. All right, last one, we'll plug in 6. So let's see, we're going to have negative 4 times 6, and then plus 23 over 6 minus 4. We want to know if that's less than or equal to 0. So we're going to get negative 24 plus 23 all over 2. Is that less than or equal to 0? So you end up getting negative 1 over 2. Well, negative numbers are all less than or equal to 0, so that comes back as true. And so we'll go ahead and shade. And so that interval is going to be from negative infinity to 4, not including 4. But then when I union it, over here, I am going to include the 23 over 4, the x-intercept, and then it's going to continue on to positive infinity. Okay, so just a little note. So we did 6 of them. You can basically expect one of each type that we solve. So you can expect 3 of these on the exam.